In this video, we're going to do the integral of x squared over 1 plus x squared dx 3 different ways. So the first way we're going to do it is by trig sub. So x equals tangent theta, dx is secant squared theta, d theta. So plug that in, so we get that the integral of x squared over 1 plus x squared dx equal integral of tangent squared theta over 1 plus tangent squared theta times secant theta d theta, secant squared theta d theta, because dx is secant squared. So this would be the integral of tangent squared theta. This is secant squared theta, so this and this would cancel. So you're left with integral of tangent squared theta d theta. So there's a couple ways to do this. Easier way is just to say that's the integral of secant squared theta minus 1 d theta. So this will be the integral of secant squared theta d theta minus the integral of theta of 1 is just theta. The integral of secant squared theta is just tangent theta minus theta. And tangent theta, so we know that x is tangent theta. So that would be x minus theta. So theta is the inverse tangent of x. So this is just x minus inverse tangent x plus c. So that is one solution. Another way to find this integral is to do long division. So we want to find x squared over x squared plus 1, another value for this. So this will be x squared divided by x squared plus 1. So this equals goes to the top. So we need a 1 to go into x squared plus 1 to get x squared. So we multiply that. So it would be x squared plus 1. You subtract everything. And this is plus 0. So 0 minus 1 is minus 1. And x squared minus x squared is 0. So this will just be 1 minus 1 over x squared plus 1. This integral will be equal to the integral of 1, which is just x, minus the integral of 1 over x squared plus 1 dx, which is just x minus inverse tangent x plus c. That's another way. So this is the third way to do it. This is the way I would do it on an exam. So you have the integral of x squared plus 1 over x squared plus 1, and you have minus 1 dx. So you've put parentheses around those and you separate the integral. So you have the integral of x squared plus 1 over x squared plus 1 dx minus the integral of 1 over x squared plus 1 dx. So this term is just 1. So the integral of 1 with respect to x is x minus this integral is inverse tangent x plus c, and that's the answer. So if we integrate x squared over x squared plus 1, and this is not a good way to do it, but you can do the integral of x over x squared plus 1 times x dx. We'll use integration by parts or DI method. So we're going to differentiate x. We're going to integrate x over x squared plus 1. We're going to multiply by 2, and we have to divide by 2, so we have 1/2. So the integral of 2x over x squared plus 1, well, that would just be 1/2 ln absolute value of x squared plus 1. The derivative of x is just 1 plus minus, so we'll have the integral of x squared over x squared plus 1 dx equal to 1/2 x ln absolute value of x squared plus 1 minus 1/2 integral ln absolute value of x squared plus 1 dx. And this will lead to a cool identity for an integral. So we found out earlier that this integral is also equal to x minus inverse tangent x plus c. Now, you could do c1 and c2, but you can just subtract them and you get just c. So we'll just move everything. We'll move the integral to one side, so we get 1/2 integral ln absolute value of x squared plus 1 dx equal 1/2 x ln absolute value of x squared plus 1 minus x plus inverse tangent x plus c. So if you multiply by 2, you get the integral of ln absolute value of x squared plus 1 dx equal x ln absolute value of x squared plus 1 minus 2x plus 2 inverse tangent x. 2c is the same thing as c, so we'll just write it as that. And that is the integral of ln of absolute value of x squared plus 1.